Hello everyone, welcome back to another tech discussion. I'm Samuel. Today, we'll learn how to build an robust and real-time multi-partner integration platform on AWS using EDA, otherwise called event-driven architecture. Well, if you want your business to connect with many partners like banks, insurers, or vendors smoothly and reliably, right? This video and this discussion is for you. Imagine you running a platform that needs to connect with many partners, and each partner has their own API, and sometimes their systems are slow or even fail. That can cause delays, timeouts, and poor experience to our users. So the way to solve this problem is through event-driven architecture. Now let's break down the solution step by step using this architecture diagram. Let me first name the different components in this architecture. Here we have the user interface, which could be a user's mobile phone or a laptop and a browser in the user's laptop. And then we have the business service there that connects with the user interface. The business service also connects with a data store. Then the business service connects with event bus. We'll look at what they are. And then we have reactive services connected to event bus. And that reactive service behind it gets connected with the partner integration services as you see. And then the partner integration services, they actually connect with the different partners that's out there. And the partner integration service is also connected with the event bus. And that event bus, in other words, it gets connected with API monitoring that has an event bus and a data store and a tracking dashboard to monitor the performance. So let's take this example. Let's take FinServ Markets, for example. FinServ Markets, they actually help customers buy financial products like, credit cards, loans, insurance, and investment, all from many different partners. To provide these services in real time, right? The FinServ market, they connect with many partners as you see, and each partner have their own way of working with APIs, which can actually cause problems. There can be delays, there can be failures, there can be timeouts, right? And today, through this architecture, right, we're going to discuss how an event-driven architecture on AWS with reactive design, how it can help solve those problems. What we have is the modern event-driven architecture. All the challenges that I mentioned, right, they are present with the old legacy systems. So the old legacy systems had these problems. They had latency issues when calling many partner APIs at the same time. It was actually slowing down the service. And then they had timeout issues. If a partner API does not respond on time, right, it can actually affect the whole system. So they had timeout issues. And then failures, they had to deal with failures. If a partner's API fails, right, it can actually cause the service to fail or slow down at the least. So that was an issue that needed to be tackled. All this was bringing down the customer experience. It's hard, very hard to keep a smooth experience for users when the partners' APIs have issues. So all of these issues will happen in a traditional synchronous system where one component waits for the other component to respond before it can go back to the next step. But with an event driven architecture like this, right, these types of architecture, they give an consistent experience to our customers even when the partner APIs have problems. And this diagram here, it shows the main parts of our solution. We already named the different parts of the solution. Let's go a little bit in depth and understand what they do. For example, what the user interface does, what the business service does, what the event bus does, what the reactive service does, and what the partner integration service does, on and on. Right? So the user interface, this is the single page application that's running in the user's browser. For example, the UI in the user's browser, right? They send a request. Let's say they send a request to calculate insurance premium and they get an unique ID. This lets the UI, so this unique ID lets the UI show partner responses as and when they come in. Then there is business service. This is a microservice that provides API for the UI to send requests and to receive responses from partner services all in a reactive way. Then there is event bus. This system actually moves and routes events to the right service. The business service sends an event for each partner quote request, and the reactive services there listen to these events. Talking about reactive services, these services they get events and they call the API or the partner APIs out there. And when they get the response back, right, they call back the business service API and provide that response. And then there is partner integration service. Now this service connects to the partner. It actually changes the standard request into the partner's requested API format. It handles security, it actually manages errors, and there is one for each of those partners out there. This is a conceptual architecture. Now the same can be built, or the same has been built using Amazon Cloud Services. Let's discuss that. Now let's realize that solution in AWS. Now this model architecture is actually built using AWS Cloud Services, like the way you're looking at it right now. There is user interface. It's built with Angular and it's hosted on Apache servers inside Amazon ECS container service. And the elastic load balancer there inside that ECS, right? It spreads traffic evenly. Then there is business service. This business service is built using Spring Boot running in Amazon ECS containers. And the elastic load balancer there, it actually balances the load it receives. And this setup is flexible and it's scalable automatically. Then there is data store. We use different databases depending on the product and the data needs. For example, here we have used Amazon Aurora Postgres and Amazon Elastic Cache, which gives us the right mix of speed and durability. Then there is Event Bus. We are using Amazon SNS for event publishing because it best fits the volume and the use case. For some tasks like calling APIs of selected partners, right, we can use Amazon SQS for queuing the asynchronous work. Then there is reactive services. This reactive service is built with Spring Boot on ECS and AWS Lambda function. At a later point, we can also use AWS Lambda for all those services if you want better serverless scaling. That's an option. And then we have partner integration service. This service is the one, like I mentioned before, it translates between the standard API and the partner specific API. It also handles retries, it handles errors, like using exponential backoff when it has to do retries. And then there is partner API tracking. Here we use Amazon OpenSearch service and Kibana to track API calls and detect the failures. Using this tracking method, we can stop calling a partner temporarily if the failures with the partner are too many. Now, this solution solves all the problems we discussed before when we use multi-partner integration. For example, latency issue is solved. The UI here, it actually polls for partner responses automatically. So it shows the fastest responses first. So users don't have to wait for those slow partners. They can like ignore them and move on. And then the timeout issue, that's sorted out. The UI actually sets time limits for waiting. If the partner doesn't respond in time, right, the UI stops waiting without hurting the whole user experience. And then the failures. If the partner API fails, right, the UI generally or gracefully times out that connection. And then the tracking system, they can down the line disable a failing partner automatically. Talking about customer experience after this, the user sees partner offers as they arrive and they can choose without waiting for all the responses to come in. And this is what the customer want most of the time. Now here's a real world scenario where a user called JL wants to buy a new insurance policy for her car using an online insurance marketplace. Let's look at the user experience or the user flow of JL purchasing the car insurance through the portal. So now JL visits the insurance portal on her browser. There, the rich user interface built with Angular and delivered by Apache running on ECS, right? It takes the load quickly and then provides her with an easy to use form to enter her car details and personal information. Then JL submits her insurance request. The information is sent to the backend business service, Spring Boot app on ECS here. And this service validates her details and stores them in a data store, Aurora, Postgres, or Elastic Cache in this case. Then the business service publishes an event to the event bus using AWS SNS or SQS. Now this is the event that represents JL's request for insurance code from multiple partners. Now the reactive services. The reactive services, they are implemented as Spring Boot apps on ECS or on AWS Lambda functions. They listen for the new events on the event bus. When JL's requests arrive, these services process it and prepare it for integration with various insurance partners. Now, when talking about each partner integration services, they actually run Spring Boot on ECS. They receive the processed request and they translate it into a specific format required by each insurance company. There's n number of companies, partner 1, partner 2 till partner n, right? And these services then send code requests to the partners APIs. Now when the partners respond with code, right, the integration service sends the results back through the business service, which updates the data store. The user interface polls for updates and display new codes to JL in real time as they arrive, allowing her to compare offers immediately. She does not have to wait for all the partners to respond. All the API interactions and events are actually logged in an API data store called Elasticsearch, and that's monitored using Kibana. Now this setup here, the API monitoring setup here, it ensures that any failures, any delays or issues with partner APIs are all tracked, and the system can alert the administrators or sometimes even temporarily disable the problematic partners to maintain a smooth experience for JL in buying her car insurance. Now through this event-driven architecture, JL experiences a fast, seamless process. She submits her details once, receives multiple insurance quote in real time from different providers, and can make an informed decision quickly, all powered by the event-driven architecture behind the scenes. The event-driven multi-partner integration architecture with AWS behind the scenes. Let's look at another scenario where a user called Stabita, for example, wants to book a flight, hotel, or a rental car. Now this platform well suits for that type of application as well. The platform must check the availability and price for multiple airlines, hotel, and rental agencies all in real time. That's the scenario here. So let's see how it works. The user Tabitha enters travel details in the web app. That's rich with user interface. That's the rich user interface. And then the business service processes the request and stores it. The event is published to the event bus. There's SNS and SQS, and then the reactive services pick up the event, and the partner integration service sends requests to all travel partners, that's the airlines, hotels, or even car rentals. As the responses arrive, right, the UI updates the user Stabita with options all in real time. And parallelly, all partner API calls are monitored and logged for reliability and analytics. Let's look at another scenario where a customer called Arpita wants to apply for personal loan and wants to see offers from several banks instantaneously. Let's see how it works. Now, a user called Arpita fills out a loan application on the portal. The application is processed by the business service and then it's stored. The UI, the ID is stored, and even triggers a loan quote request to multiple banks via the event bus. Each bank integration service handles this specific API request and returns the loan offers. Then the user Arpita sees offers from different banks as they arrive. This allows her to quickly compare the selection. While all this is happening, API monitoring tracks the partner response time and failures for compliance and quality. Then the user Arpita gets an seamless customer experience by using this event-driven architecture all decoupled. So this architecture is very powerful because it handles delays and failures without blocking users. It's easy to add new partners just by connecting another integration service. That's all is needed. And it can scale automatically because AWS serverless components are used here. And also it gives us the full visibility with real-time monitoring. We can understand what's going on behind the scenes. If you are building a platform that connects with many partners like fintech, travel, healthcare, or e-commerce, right? This event-driven architecture is a great choice. It's cost-effective, reliable, and very much future-proof. I'll talk to you on another video like this. Thank you.